Hello everyone. So welcome back, and today we are going to do with the topics of trigonometry. We are going to talk about the basics of trigonometry. We're going to talk about the previous knowledge, the knowledge that we acquired from class 10th chapter of trigonometry. Okay. So today what we are going to do is first we are going to talk about angles. Okay. How is it formed and what is trigonometry? What basically is it trigonometry and how is it related to angles? Okay. Second, we're going to talk about relation between degrees and radians. Okay, so up till now, what happened was we measured angles in form of degrees. Okay, and further forward, moving on, we'll be measuring angles in the form of radians. And what is it? We are going to talk about it. Then we are going to talk about trigonometric functions. Previous knowledge that we had about trigonometric functions, all the values for certain angles, we have certain trigonometric ratios. Now beyond those angles, beyond angle 90 degree, what are the values of the trigonometric ratios? They exist, okay? Since they exist, therefore we are going to talk about them. So first thing that we talk about is angle. Since it's the basic of trigonometry, therefore, what is an angle? Okay. So for an angle, what we need is to understand what a ray is. Okay. So say a ray is traveling in this direction and it is shifting in such a way that it is moving upwards. Okay. So the shift, the measurement of shift, of a given ray with an axis that is fixed, okay, so that measurement is called angle. Okay, so this is called initial side and this is called terminal side. All right, this is what angle is. Clear? So moving further, we usually measure angles in degrees. Okay? All right? Say in a complete circle, the angle is 360 degree. All right? This is the symbol that states the measurement is in degree. Okay, 1 degree. Now this 1 degree is further simplified into minutes. Okay, 60 minutes. Even moving further, 1 minute is further classified into seconds. Okay, so that is how we usually measure angle, and these are certain units that we usually measure in. Okay, as far as class 10th is concerned. All right, now moving into class 11th, moving further from degree, next we are going to talk about the degrees that is measured in radians. So how do you measure in radians? Next, we are going to talk about the relation between the degrees and radians. Okay, so first thing, what is radian? All right, so radian is actually the angle. Okay, radian is the angle which is subtended when the radius r, okay, and the arc r, the sector AOB is such that the radius is r and the arc's length is also r. So in certain sector, angle subtended in a sector whose radius and arc are equal. And the arc, or you could say, and the arc subtended are equal. All right. So what is happening is radius r is being wrapped around the sector. Okay. This is also radius r. This is also radius r, and the sector's length is also r. That is the part that we are going to take. Okay. And in that case, the angle, the theta that is being subtended, is called 1 radian. Simple. Okay. So let's find the value of 1 radian, or let's say in an arc, in a sector AOB, let's say angle AOB divided by angle AOP is equal to, now this is a basic part of similarity, since it is the sector of a same circle. Therefore, in terms of the ratios of the angle, we can say that this is equal to the arc AB upon arc ABP. Okay. Clear? Since this is a part of the same circle, therefore the ratios are equal. Now angle AOB, in this case, this is the angle AOB. Okay. Similarly, angle AOP, it is a straight line. Okay. Angle on a straight line. So what is the angle on a straight line? It is equal to how many? 180 degree. So angle AOB divided by 180 degree is equal to arc AB. Okay, this arc AB, which is equal to radius r divided by arc ABP. ABP, this whole arc. Okay. Now this whole arc is the arc of a semicircle, or a circumference of a semicircle. So what is the what is the circumference of a complete circle? It is 2 pi r, half it, and you're going to get the circumference of a semicircle. Okay. So from 2 pi r, if the 2 is cancelled, you're going to get pi r. Now this pi r is the semicircle circumference of the semicircle. Okay. Now radius cancels out, and from here we have angle AOB is equal to 180 upon pi. Okay. Now this angle AOB is the angle such that it is a part of sector where the arc is equal to the length of the radius as well. Okay. So this is actually equal to 1 radian. Okay. Now since this is 1 radian is equal to 180 degree upon pi. Everybody knows what a pi is. Okay. Now pi is being sent over here after transposing pi over here. So we can write pi radian is equal to 180 degree. Okay. So further from here, we are not going to talk about the angles in form of degrees. What we are going to talk about is angles in the form of pi radian. Okay. For example, if I have to say 90 degree, instead of saying 90 degree, I'll be saying pi radian divided by 2. Okay. Or you could say pi by 2 radians. Simple. Okay. So this is one basic part that needs to be learned in class 11th, because further from here you'll be always using pi as in form of angle. So the measurement of the angle will always be in the form of pi. Clear? Now that being said, the measurement of angles will be in the form of pi radians. So how do you convert a given angle into radians? Okay, a given angle in the form of degrees into radians. Okay, so for example, we have pi radian is equal to 180 degree. Simple. Okay, so we should be having pi by 2 radians to be equal to 90 degree. Simple. Okay, and moving so further, for example 270 degree, what is the value in the form of pi radians? Okay, so there's a simple method with which you can find the value of angles in the form of pi. All right, for example, let's say for 360 degree, to find in form of radians. Okay, now this is in degrees, now you have to change into radians form. So what do you do is you simply multiply the given angle in degrees into pi upon 180. So if you multiply this, what happens? 18 twos are, this gives me 2 pi. Okay, so any angle in the form of degree can be formed into pi radians as well. Okay, simple. So as we move further and further, what we do is we simply say that pi is equal to 180 degree, which is mathematically wrong. However, to prove keep on stating pi radians equals to 180 degree, so we simply just say it as pi equals to 180 degree. Instead of saying the whole sentence, we just use pi equals to 180 degree. Simple. So similarly for 270 degree, to convert it into radians, we have 270 degree into pi by 180. Okay, so if you divide it, what happens? 920 is a 930 is a 0 and 0 cancels, so you are going to get 3 pi by 2. Is it clear? All right, so moving further in the topic of trigonometry, next we are going to study about trigonometric functions. What is trigonometric functions? All right, so as far as we are concerned, we did certain topics about trigonometry in class 10th, and you must be knowing certain ratios as well. Okay, and these are very popular ratios. Okay, everyone talks about them. First ratio, sine. Okay, it's actually pronounced as sine, but we write it as sin, which is a short form of what it actually represents. Okay, clear? Similarly, next ratio that we have is called cosine, and it is written as cos in the short form. Third important ratio is tangent. Okay, we pronounce it to be tangent, but we write it as tan, again for simplicity. Okay, and then for certain values of angle, for example in 10th we talked about 0 degree. Okay, next angle would be 30 degree, next would be 45, and then next 60, and then 90. These are the certain ratios that we used. Okay, and as we move further, so these are the trigonometric ratios that we talked about in class 10: sine, cos and tan, or sine, cosine and tangent as we know them to be. For the angle 0 and 30 degree, 45 degree, 60 and 90 degree. Now as I said earlier, we'll be using the angles unit in the form of radians instead of degrees. So first thing, instead of writing 0 angle, we'll write it 0. There's no change in 0. Next, in 30 angle, 30 degree, instead of writing 30 degree, if we calculate it by multiplying simply with what? Pi upon 180 degree. So we are going to get pi by 6. Simple. Okay. Similarly, for 45 degree, if you multiply 45 with pi by 180, you're going to get pi by 4. Okay. Next one, instead of writing 60 degree, it will be pi by 3 radians. Okay. And lastly, instead of writing just 90 degree, you'll be writing pi by 2. Okay. Now, this is a step further. Okay. Slightly step further in the topic of trigonometric functions. Okay. In the sense that instead of writing angles as 0, 30, 60, 45 and 90, we'll be writing 0, pi by 6, pi by 4, pi by 3 and pi by 2. Is it clear? Alright. So everybody knows the various ratios. What does sine for certain angle holds? What does sine for certain angle? Cos for certain angle holds. Okay. For example, for sine 0, it would be 0. Clear? Okay. Sine pi by 3, it would be 1 by 2. Alright. Sine pi by 4, it would be 1 by root 2. Clear? For sine pi by 3, it would be root 3 by 2. And for sine 90, it would be 1. Clear? Alright. So for cos, it would be 0, 1. Okay. And then cos pi by 6, it would be root 3 by 2. And cos pi by 4, it would be 1 by root 2. For cos pi by 3, it would be 1 by 2. And then for cos pi by 2, it would be 0. Simple. Now for tangent certain angles, tan of 0 would be 0. Tan of 30 degree or pi by 6 would be 1 by root 3. For tan 45 or pi by 4, it would be 1. And for tan pi by 3, it would be root 3. And for tan 90 degree, it would be undefined. Okay. Here. So this is the various previous knowledge that we had about trigonometric ratios and the table. Okay, simple. Now again, if we talk about sine, tan, cos, where does it originate from? Okay, and the main concept that lies behind the origination of the certain ratios is always about a right angle triangle. Alright. Now, right angle triangle has three parts generally. The first one, let's say this side is called base. Okay. And base is the part or the side that usually contains the 90 degree and the required angle degree. Okay. These two angles are always based on the side that is known as base. Next, we have this side being called as perpendicular. Okay. And last side, this longest side is known as hypotenuse. Okay. Clear? So we have three sides of three triangles, and based on three sides, the whole concept of trigonometry is formulated. Okay. And wherever we go, when we talk about trigonometry, we heard many people say, what is trigonometry? How is it useful in daily lives? Alright. You must be hearing your parents say, maybe your brothers talk about trigonometry, as they say, when I go to shopkeeper, I never use trigonometry to buy my vegetables. But they do not realize how important a trigonometry is, or the study of trigonometry is. Okay, its importance lies in the concept that it is extensively used in all the scientific studies. It is extensively used in medical sciences. It is extensively used in our own daily life. It happens around us every time. Okay, for example, in a pendulum, the best example to state is a simple pendulum. What happens in pendulum? It moves like this. Okay, it goes up, it goes down, it goes up, it goes down. So that motion can best be represented through trigonometry. Alright, something that repeats, okay, is usually represented in form of trigonometry. So moving further, as I said, trigonometric functions is based solely upon the triangle that has 90 degree in it. Alright, or also known as right angle triangle. Alright, now based on three sides, what happens if I divide the two sides? Okay, so we named the first ratio where we divided the two sides perpendicular and hypotenuse as sine angle, sine of the angle. Okay, and this ratio will also remain always constant for the certain angle theta. For example, if the angle is 30 degree, then the ratio would always be in the form of for sine 30 it's half. Okay, so it will always be half. No matter what the size the triangle holds, this ratio will always stay half. So that concept needs to be understood. Okay, so these three ratios needs to be understood. So whenever we talk about certain angle, the sine of the angle will always be the ratio of the perpendicular of the right angle triangle by the hypotenuse of that same triangle. Simple. This ratio is known by the name sine of the theta. Okay. Now, how is it important? What is the significance of this angle and how is it related to this ratio? Alright, so as we talked earlier about certain ratios or certain angles having specific ratios, for example, we said that for sine theta being 30 degree, it will always be, or instead of writing 30 degree, let's write pi by 6. Okay. So for sine 30 degree, the ratio is always 1 by 2. Okay. Now what is the significance of this ratio is whatever happens, however big the triangle may be, however say in the form of size, however enlarged it may be, the ratio of the perpendicular to hypotenuse if the angle is 30 degree. Okay. Are you understanding me? So for the angle 30 degree, the ratio of the perpendicular upon hypotenuse will remain to be 1 by 2. Clear? Okay. So let's say we have a smaller triangle. Let's say this angle is 30 degree and we have a bigger triangle. This is also 30 degree. Okay. So in that sense, if let's say this length is 2 centimeter. Okay. If this length is 2 centimeter, this length being the perpendicular. Okay. In that case, this hypotenuse would be how much? And this hypotenuse should be equal to how much? It should be equal to 4. Okay. Why? Because for sine 30, the ratio of perpendicular upon hypotenuse is always half. So for this triangle, sine 30 would be equal to perpendicular is how much? 2 centimeter. What about hypotenuse? It should be, let's say, x centimeter for time being because we didn't know what the length of the hypotenuse was. So sine 30 is how much? Half. Everybody knows that. So for half equals to 2 upon x. Therefore, x should be equal to 4 centimeter. Alright. Clear? So using the angle and the length of one side, what we can find is the length of the other side. Clear? Now since two lengths are found, what about the third side? Which is always easy to be found since we have been finding this angle, since we've been finding the third side from class 8th, if you remember, and the concept to be used is Pythagoras theorem. Simple. Pythagoras theorem, hypotenuse square equals to perpendicular square plus b square. So what we did is instead of trying to find two sides and finding the third side, what we did is we used the angle and one length alone to find the length of the third side as well. Okay, now that is also a part of trigonometry application in class 10th, if you remember that. Okay, so moving further, we are going to focus on certain formulas. Like for sine, for cos, it's based upon hypotenuse. For tan theta, it is perpendicular upon base. Likewise, we have certain inverse trigonometric, so not actually inverse but reciprocal. Okay, for reciprocal of sine theta, we have 1 upon sine theta equals to cosec. Okay, so for the reciprocal of sine theta, we have cosec theta, or also known as cosecant. Okay, the name actually is cosecant, but we write it in a short form as cosec. All right. Next, similarly for cos theta's reciprocal, we have secant, or in short form we write it as sec theta. Okay. Likewise for tan theta, it would be cot theta. Okay, this was done in class 10th, if you remember. So similarly, for certain formulas like sine theta, cos theta, and tan theta, we have reciprocals cosec theta, sec theta, and cot theta. All right. For tan theta, we have one more formula. Tan theta equals to sine theta upon cos theta. Simple. Okay. These are certain formulas that we did in class 10th. Now let's talk about trigonometric functions, and first ratio that we are going to talk about, let's talk about sine theta. Okay, as far as sine thetas are concerned, we were knowing about the values of sine theta, where theta being 0, where theta being 30, 45, 60, 90. Okay, now as we move further beyond 90 degree, and then one more thing, if you need to know this, between angle 0 to 30 degree, there are many angles, not just 0 and 30 degree. There are 15 degrees, 20 degrees, all right. And for every trigonometric function, for a certain angle, there should be a ratio, and there is a ratio, all right. Now that being said, what about angles between 0 to 30? Say for example for 15 degree. So does sine 15 exist? Yes, it does exist, and for sine 15, we have certain ratio. Okay, for that ratio, we need to use trigonometric table. Okay, and using of table is something different. It is slightly comparing the ratios and with the angles and then finding the values. Okay, so that does not, if it's not written here, does not mean certain angles the ratios are not evident, but for certain angles, all the angles, for any value of angle, the ratio is available. Okay, so that being said, now one thing we can talk about sine theta is it is continuous function. Okay, it is continuous function in the sense that let's say y is equal to sine x. Okay, where x is what? X is the value of all the angles as we place them. Okay, and after placing the value of the angles, the ratio that we are going to get is the value y. Okay, so this is a function, okay, with a certain domain and range. Simple. Now that being said, how do you understand this? To understand this, we have a basic circular diagram. All right, and this diagram I'm going to show how a sine ratios come about and how they can be represented. All right, so first thing that you need to know is it's a circle whose radius is a unit, 1 unit. Okay, the length of the radius is 1 unit. So what happens is, as we move this ray, or as we move this radius by certain angles, okay, what is going to change is we are going to change the length of this side. Okay, Clear? So for certain angle between 0 to 90 degree, from 90 degree to this is 180 degree, and from 180 to 270 degree, and then from 270 degree to 360 degree, what is happening is the length of this line is increasing or decreasing. And how is it increasing or decreasing? We are going to check it out. Okay, let's say this is the center O, and this coordinate is 1, 0. Okay, clear? Similarly, this coordinate is 0, 1. This coordinate would be -1, 0. Likewise, this coordinate would be 0, -1. Okay, simple. So first thing, let's talk about angle pi by 6. Okay, so if this ray moves by angle pi by 6, let's say it moves up till here, and this angle is, let's say, this angle is, say, pi by 6. So it has moved by pi by 6 up till this point. Okay. Now this value, sine x value, is the value of this length. Alright. And similarly, what is x? X is this value. Okay. So what is happening? For pi by 6, the value of sine x is this length. Okay. And for simplicity, let's say it is half, 0, sorry, 0, half, 0, half. Okay. Simple. So we know that at sine pi by 6, the value of sine x is half. Okay. So y equals to half when x equals to pi by 6. Okay. So let's move further. For x equals to pi by 4, value is slightly increased. Y is equal to, as we know, it should be how much? 1 by root 2. Okay. So 1 by root 2 is slightly greater than half. Simple. Why? Because the remainder is dropping down. Okay. As the, sorry, not the remainder, the denominator is becoming smaller. As the denominator is become smaller, the whole number itself increases slightly. Okay. So for certain angle pi by 4, what happens? The value of y increases slightly more. Clear? Okay. So likewise, it goes on increasing. Now at a certain angle, let's say what is this angle? This angle is 90 degree. So for 90 degree, the length of y-axis is maximum. By how much? It is unity. It is 1. Okay. So for x equals to pi by 2, y equals to 1. Is it clear? Alright. Now I'm trying to change the angle further and further. Let's say instead of 90 degree, I increase it. Keeps on increasing. The angle is increasing. Angle increases, let's say, up till this point. So this angle is 180 degree, or let's say x equals to pi. Okay. Now since x equals to pi, what is the value of y, which is equal to sine pi? Okay. Sine pi is 180 degree. What should be the value? It should be the length of this axis. Okay. Maximum is 1, but over here, what is the value of y? The y over here is 0. Simple. Okay. As we move further, let's increase this angle up till over here. So as you can see, 190, 290 and 390. So when x equals to 270 degree, 3 pi by 2, y equals to how much? At this angle, the length of y is this whole length. And what is the value of this length? It is minus 1. So y equals to minus 1. Okay. Now for simplicity, I am taking certain angles by which I mean at a multiple of 90 degree. Okay, at a multiple of pi by 2. So that's for simplicity. There are certain values over here as well. And how do you find it? We'll be talking about that later. So first thing, we'll talk about this angle as well. Now this whole angle is a complete angle, a circle in the form. What is the angle? Angle is 360 degree. So when x equals to 360 is 2 pi. Okay. So when angle is 2 pi, what is the value of y? The y coordinate is 0. So y equals to 0. Okay. Now if you add 90 upon 360, so it goes again over here. Then again the y would be 1. Clear? Okay. So this is the basic concept of finding certain values beyond 90 degree for sine function. And for cos function, what we do is, instead of considering the y coordinate for sine function, what we are going to consider is the x coordinate. Okay, the length of the x-axis. Is it clear? So as we move further in the cos part, what happens for cos part is the value of the x-axis is taken into consideration. Alright. So for sine theta, for 0 it was 0. For sine 30 it was 1 by 2. Pi by 4 it was 1 by root 2. For pi by 3 it came out to be how much? Root 3 by 2. And for 90 it was 1. Now what about sine pi? So sine pi, as you can see, is how much? 0. What about sine 3 pi by 2? 270. So for sine 3 pi by 2, y came out to be minus 1. Is it clear? Okay. So quickly let's do it for cos as well, so that you can understand. For the cos, we are going to check out the x-axis. Okay. So for cos theta, angle 0, pi by 6, pi by 4, pi by 3, and then we have pi by 2, and then we have we have pi, 3 pi by 2, and then let's stop at 2 pi. Okay. Certain ratios. So first thing, for angle 0, the cos value will be the length of x-axis. So this is the line for 0 degree. Clear? What is the value of x? 1. Therefore, cos 0 is 1. Okay. Now for cos 30 degree, what happens? We have a certain angle over here. Okay. Now over here, what is happening is x is getting reduced slightly. Okay. So how much is cos 30? Root 3 by 2. Okay. Now value is decreasing for cos. As we are moving away, this length is decreasing. Okay. For example, for certain angle over here, the length is shorter. Okay. So x-axis gets decreasing. Okay. And then we move here, it moves that side, further decreases. Alright. So next, for cos pi by 4, it is 1 by root 2. Cos 60 it is 1 by 2. For cos 90 it is 0. Now what about cos pi? The value of cos pi. Okay. For pi it is 180 degree. At 180 degree, cos pi value is, the coordinate is x coordinate minus 1. Abscissa is minus 1. So minus 1. Now as we move at 270 degree, this line is for 270 degree. What is the value of x coordinate over here? 0. So cos 270 degree is 0. As we move further, we came over here. What is the value? 1 for the angle 2 pi. So cos 2 pi is 1. Clear?